All right, guys. Today we are going to learn how to solve a rational equation. So the objective today is I can solve a rational equation using the least common denominator. Okay? All right. So we are now ready to solve rational equations applying much of the factoring and simplification skills we have mastered earlier in this unit. Okay, so there's a distinction between what we did earlier and what we are about to do. So in all the things we did earlier, all we did is deal with expressions, right? We simplified expressions, right? We multiplied, added, subtracted, divided. We factored them, all kinds of different things. And the distinction between what we did earlier and what we're about to do is an equal sign, okay? So remember that an equation is an equation because it has an equal sign. Okay? Without that, it is just an expression. So if you think back and you can kind of remember the problems we were dealing with before today, there was no equal sign. So they were just expressions. It says previously we just simplifying for the sake of simplifying. Now our goal is to simplify and solve for a variable. Okay, and if you look here right below, there's a box with a bunch of different steps. I'm actually going to add a step in here that I forgot to type into this note sheet, and I apologize about that. But I'm going to write it right underneath factoring all denominators, okay? So I'm going to put, this step should really be 1b. Do you understand? This step is 1a. This step is 1b. I'm going to put find the excluded values, okay? And if you remember from our discussions previous to this particular lesson, an excluded value is a number that makes the denominator 0. So a number that I plug in for the variable that makes the denominator 0. Because all a rational expression is division, right? And we all know, based on our mathematical work throughout our careers, that you cannot divide by 0. And the reason you can is because division means breaking things into groups, correct? So 8 divided by 2 is saying, how many groups of 2 are there in 8? Well, there's 4, right? So if we were to divide by 0, that would be saying, so 8 divided by 0 would be saying, how many groups of 0 are there in 8? Does that make any sense? Can you have a group of 0? No. So that's why it's undefined, and that's why we need to find those values. Because if those values happen to be our solutions, they can't actually be our solutions if they make the equation undefined. All right? All right, here we go. Let's do example numero uno. So example 1. Okay, if we notice here, guys, this is actually a proportion, yes? And that's something that you guys have dealt with a lot throughout your years in middle school. So if we have a fraction equal to a fraction, guys, I'm not going to worry about any of these steps. Do you understand? I'm just going to cross multiply. You got me? Okay. So I know all those steps say a bunch of different things. I would just cross multiply. There is one thing I want to make sure you guys are paying attention to. So please turn your listening ears on. If you notice in the denominator for both of these, you have a 15 and a 5. Okay. I know in the steps here I said find the excluded values. Do you guys agree there are no excluded values, right? Because the denominator in both of these are going to be that number because there are no variables that I can substitute a number into. Does that make sense? So the denominator here is 15. There is no way I can make 15 0, right? Because it literally is 15, right? Do you guys get that, right? I mean, I could multiply each side of the equation by 0, but that would be, I mean, there's no use to that, right, if I'm trying to solve. Does that make sense, everybody? Okay? So in this particular case, there is no excluded value because there is no variable in the denominator, right? There is no number I can plug in that would make the denominator 0. All right. Anyways, let's solve this thing by cross multiplication. So I'm going to multiply those two, and I'm going to multiply those two. Okay, so if I were to multiply those two in blue, that would be 5 times x minus 1, and that is equal to what I did in red. 15 times 2 is 30, right? Okay, and now all I have to do is solve for x. There's a couple different things you could do. You could distribute your 5 through, or you could notice that 5 is indeed a factor of 30. So I'm going to divide by 5 and divide by 5. My 5s are going to divide out to equal 1. I get x minus 1 is equal to 6. So x is equal to 7, right? I'm going to add 1 to both sides. So x is equal to 7. Make sense? Okay, now if you were to plug that back in really quickly, just to show you guys that 7 minus 1 over 15 is equal to 2 fifths, right? 7 minus 1 is 6, so that 6 over 15 is equal to 2 fifths. I can take a 3 out of both, so that'd be 2 fifths is equal to 2 fifths. Therefore, we have our solution, and it is correct. You guys don't have to check these, right? You only have to check radical equations. But I just wanted to make sure you understood that that was indeed the answer, right? And you understood what a solution actually meant, correct? What a solution means is the number 7, if I were to plug it in, it makes the left side equal the right side. Do you understand? So that's a distinction that you're going to want to make sure you know for when we move on to section 2.3 in inequalities, okay? When we talk about solutions, that's saying if I find a solution that the left side, that number is making the left side equal the right side. All right, let's talk about example number 2, okay? So we're going to go to the right here. So this is example number 2, all right? Okay, in example number 2, we have 3 different fractions, okay? And the first thing, the first step says to factor the denominator. I hope all of you guys agree that um, there is no factoring that has to be done. Okay. The second thing, 1b, we said was find the excluded values. So what are the values that x cannot be? What are the values that if I plug in a value for x, it makes the denominator 0? Well, an easy way to do that, guys, and I would, again, if you can see this, especially after you've done this 2 or 3 times, you're going to be able to see it, and you don't necessarily have to write this down. But I would definitely write it down here at the beginning so you get in the mind frame of what's going on, okay? So do you guys agree there is an expression here in the denominator, yes, of x plus 4, right? And since there's a variable in there, I can plug in a number for x that would make it 0, which means there is an excluded value in that particular denominator, right? So what I would do is we want to find the value that makes this expression x plus 4 0. So I would take the expression x plus 4 and I would set it equal to 0, right? I'm going to subtract 4, so I get x is equal to negative 4. So do you guys agree that if I were to plug negative 4 back into here, negative 4 plus 4 is 0. Therefore, it would make the entire equation undefined because you can't divide by 0. So one of our excluded values here, so excluded values, is x cannot equal negative 4, right? Okay. My next denominator here is x. So if I were to take this guy and set it equal to 0, x 0, well, x can equal 0. Do you guys agree? Right? So another excluded value here is 0. And if I were to take the last one of 3x equals 0, right? Set it equal to 0, divide by 3, I get x cannot equal 0, right? Because I would substitute 0 in. That would also give me a 0 in the denominator, which would make it undefined. Okay? Alrighty. If we take a look at step number 2, it says, uh-oh, my screen is stuck here. No. One sec, guys. All right. It says find the LCD. Okay, I can't see the steps because I zoomed in here. Okay, so it says find the LCD, which is the least common denominator, right? So for example, guys, if you looked at example number 1 where it had a 15 and 5, we could easily see that the least common denominator here is 15, right? Because all I would have to do is multiply 5 by 3. And the reason I would only multiply 5 by 3 is because does 15 already have a 5 in it? Yes or no? Yes. Okay. So let's talk. Least common denominator. Okay. Do you guys agree that my denominator must have a factor of x plus 4, right? So x plus 4 is going to go in my denominator. My denominator must have a factor of x in it, right? Okay, and notice I have the same factor here, don't I? Right? Of 3 and an x, right? So I only have to write them one because that factor shows up twice, right? Do you guys understand that? Just like in 15? Do you guys agree? The factor of 5 showed up twice, so I only write it once, correct? Right? It only shows up once in 15. You guys understand that? Okay. All right. And then the last number I would need for my common denominator would be 3. Okay. So my least common denominator here is x plus 4 times x times 3. Okay? Now, the next step here says that I'm going to multiply every term of my least common denominator by, I'm going to multiply every term of my rational equation by the least common denominator. Okay, so we're going to do that right now. So in blue, I'm going to multiply x plus 4, x, and 3 over 1 by the first term of my rational equation, which is 2 over x plus 4. Okay, I'm going to do a subtraction, and then I'm going to multiply my LCD again of x plus 4 times x times 3 over 1 by my second term, which is 1 over x, right? Okay, and then this is equal to, I'm going to multiply the last term of x over 2 over 3x by my least common denominator of x plus 4, x, and 3 over 1 times 2 over 3x. Okay? Now, I know that's a lot of work, but I don't think it's too crazy or hard to understand. So this is why you do this, guys. Okay? Do you agree that if you have an equation, you can do anything to that equation as long as you do it to every term, right? Whether that's dividing or multiplying, right? Because we have to balance out the equation. Do you guys agree with me there, right? So I haven't actually changed the problem at all in example number 2 if I multiply each one of these terms by the same thing, right? All I've done is made the expression bigger, right, by whatever the factor is. That makes sense, right? It's essentially like a GCF, okay? So just know that I haven't changed the problem at all, okay? I've just made it look a different way. And the reason why I'm making it look a different way is so that I can get rid of the denominator. Because if you're like me and like most of the kids that I have taught, in the past, guys, I don't like fractions. I get anxious and anxiety, and I start disliking math if I see fractions, right? Okay? So I'm trying to get rid of fractions so that I can like math again. So this is the reason why we did it, okay? If you look here in this first term here, okay? So if you look here in this first term, do you guys agree that if I'm multiplying that by that, right? And this is work previously that you guys have done, we share a factor of x plus 4 in the numerator and the denominator, right? So based on our multiplication of rational work, we know that I can divide these two things out, correct? Because it's the same thing over the same thing, which is equal to 1, right? So I'm just essentially trimming the fat, if you will, right? I'm getting rid of the fluff, okay? So I did that for that one. I'm going to do it for this term now, okay? If you notice, I have a factor of x in the numerator and a factor of x in the denominator, so I can get rid of them, right? That's equal to 1. And then the same thing for this term. I have not only an x, guys, but do I also have a 3? Yeah, right? So I can get rid of all that, right? I'm going to cover this up even more so that we can see what we have left. So what we have left then in that first term, in that first green box there, we have left a 3x times 2, yes? Right? Minus what we have left in that second term box is a 3 times an x plus 4 times 1, and I'm just going to put the 1 there, right, is equal to what we have left then in the last box, right, on the right-hand side, is an x plus 4 times 2. And again, I wrote all of these in different colors so you could see what was happening, right? I divided out the least common denominator like one of the factors of the least common denominator, to get rid of the actual denominator of the problem, correct? So that we didn't deal with fractions anymore. Okay? We all good there? Now all we have to do is multiply and solve for x. And this looks like a problem that you guys did hopefully in like 7th, 8th grade. So hopefully you guys feel very, very comfortable with a problem like this. So 3x times 2 is 6x. Okay. Now I'm going to distribute. Remember, I'm distributing a negative 3, not just a 3, right? Because remember, this is really plus and negative. So this is a negative 3 times x, which is negative 3x. and then a negative 3 times 4, which is negative 12. And that is all equal to, I'm going to distribute this 2 to both terms, 2x plus 8, right? This happens to be a linear equation, right? Because the highest exponent here, the degree of the equation is 1. So all I'm going to do is get x's on one side, get everything else to the other side. So I'm going to subtract 2x here, subtract 2x here, and then I'm going to add 12 and add 12. So these go away, these go away. What I'm left with then is, what is that? 6x minus 3x minus 2x should just be x, and then 8 plus 12 equals 20. So my answer here is x equals 20. All right, let's move on to example number 3. Okay, so this is example 3. All right. First step, again, is factor all denominators. So there is one denominator that we have to factor. That happens to be this first one, this first term here. So this would be x plus 4, x minus 2. And that should hopefully give us some excitement because both of those factors happen to be in the denominators of the other terms, okay? So this is factor all denominators. Remember the second step, or the 1b that we talked about, is we want to find our excluded values after we have factored it, right? So we're going to take factors in our denominators. Remember, excluded values are values that make the denominator 0. And we're going to set those equal to 0. So x plus 4 equals 0. So x is equal to negative 4. And x minus 2 is equal to 0. Add 2. So x is equal to 2, right? So my two excluded values here are x cannot equal 2 and negative 4. Okay, all right. Remember, they can't equal those because if they did, they would make that equation undefined. Okay, all right. So next thing says to find the least common denominator. Well, remember, the least common denominator is just the denominator with the least amount of factors in it that you can use to get a common denominator, right? Well, the denominator, the least common denominator in this case, I hope everyone can see here, would be x plus 4 and x minus 2, yes? Do you guys all agree with me there, right? Since this one is already factored as x plus 4, x minus 2, right? If I multiplied that middle term by x minus 2, it would have a, so if I multiplied this one by x minus 2, it would have the same denominator, and this one, x plus 4, would have the same denominator, right? So my least common denominator is this, okay? Third set says multiply every term by that least common denominator. So let's do that. If I did that, I am going to get x plus 4 times x minus 2 over 1 times 2x plus 1 over x plus 4, x minus 2, plus, this would be x plus 4 times x minus 2 over 1 times my term, which is 2 over x plus 4, and that is equal to, what is that equal to? X plus 4 times x minus 2 over 1 times 1 over x minus 2. Okay, we all good there? Again, if you notice, in blue, that's the original equation. In red, that's my least common denominator. And we said we haven't changed the problem at all since we have multiplied both sides by that factor. Okay, and the reason we are doing this is so that we can get rid of the denominator, right? Because we do not like fractions. So for this, oops, I meant to do this in green. In this particular term, I have an x plus 4 and an x plus 4 that go away. In this particular term, I also have an x minus 2 and an x minus 2 that go away, right? Okay. For this term, the only factor that is the same is an x plus 4 and an x plus 4. Again, remember, it has to be in the numerator and the denominator because the same number over the same number is 1. And then lastly, on the right-hand side of my equal sign, I have a factor of x minus 2's that are the same that I can get rid of. Okay? So in green here, what I'm left with, I guess I'm going to rewrite this as 2x plus 1 for my first term. That's all I have left, right? Plus plus in red, I have an x minus 2, right? That's the factor of the least common denominator that stays. And then I have the numerator of my original, which is 2, and that is equal to the x plus 4 of my least common denominator that stayed, that didn't divide out, times my 1 in the numerator, okay? And again, all I now have to do is solve it, okay? So I have in green here, I have 2x plus 1 is going to stay the same. I'm going to have to distribute this 2 to both of those terms, so that's plus 2x minus 4 is equal to, if I distribute 1, that would just obviously be the same factor. And now all I have to do is solve, okay? And again, it's linear, so I'm going to get the x's to one side, the numbers to the other side, right? If it was quadratic, we do something else, so on and so forth. That's why it's so important, guys, that you can put names to things. Notice when I was solving this, I literally stated out loud that it was linear, and this is what I needed to do. I would encourage you guys to do the same thing, because do you guys agree that if you can clearly explain something in your own words, then you understand it at a very high level, okay? So if I add that up, that'd be 4x minus 3 is equal to x plus 4. I'm going to subtract x. I'm going to add 7 and add 7. See, I was doing it in my head. I'm going to add 3 and add 3. So this would be 3x is equal to 4 plus 3 is 7. Divide by 3, divide by 3. I'm left with x is equal to 7 over 3. Okay? Alrighty. Oh, look at this. So this is actually exactly what we just talked about, guys. So on the second page, this is where we describe and talk about excluded values, which we have already talked about in class. But now we're going to talk about what does it mean in terms of the context of solving a rational equation, okay? So division of 0 is not possible. We've already talked about that. So any solutions that you find that make the denominator 0 will not be a solution. We will call it an extraneous solution, okay? And this word should sound familiar, as we used it when we were dealing with radicals as well. And remember, radicals, extraneous solutions in radicals, was where after you checked it, it didn't work, okay? All right, in this case, we don't actually have to check it. All we have to do is, if the solution that we get matches our excluded value, we know that that solution obviously would not be true, okay? So it says, for example, identify whether each of the solutions is a solution, not a solution, or extraneous, okay? So the first thing we have to do is solve this thing, okay? And if we were to solve it again, this is just a proportion. So I'm going to cross multiply. So in green, I would have 2x times 4. In blue, I would have, what is that? 2. So this is equal to 2 times x plus 3, right? If I were to solve that out, that is 8x equals 2x plus 6. Subtract it over, I get x is equal to 1, yes? Okay? Alrighty. The next thing we're going to do, so that's the solution. Next thing we're going to do is, based on my denominators, what we talked about, my excluded values are x equals negative 3, so x can equal negative 3, and x can equal 0. Okay? So it says, for example, identify whether each of the solutions is a solution, not a solution, or extraneous. Okay? So let's see. 1 is a solution, right? What else? All of these other things, identify whether each of it is a solution, not a solution, or extraneous. So negative 3 is not a solution. Negative 1 is not a solution. 0 is not a solution. And 3 is not a solution. Okay, so none of them are extraneous, and we'll talk about what it means to be an extraneous solution in these examples below. All right. All right. Let's take a look at then example number 1 here on the second page. Okay. So first step, remember, is factor all denominators. The last term there on the right-hand side of the equal sign is not factored, so we must factor that. That's difference of squares, so hopefully we're all very familiar with that. That would factor to x plus 1 and x minus 1. Right? So now that we've factored all the denominators, 1b step, remember, is to find the excluded values. And the excluded values in this particular case would be what? X cannot equal 1 and negative 1, right? And I'm sorry that I didn't set those equal to 0, but I think we're starting to understand what we would need to do, right? And hopefully we can kind of do that in our head, right? All you'd have to do is subtract 1 over and add 1 over, and those would be our two values that make the denominator 0. All right? Next thing we have to do is find my least common denominator. Well, my least common denominator in this case would be x plus 1 and x minus 1, correct? Okay? Because those are the two factors that would allow me to have the same denominator for each expression, right? Third step, multiply every term by the LCD. So let's do it. In red, my LCD is x plus 1 times x minus 1 over 1. I'm going to multiply that by the first term, which is 3 over x plus 1. I am going to set that equal to, then, my LCD, which is x plus 1, x minus 1 over 1, times first term on the right-hand side, which is 1 over x minus 1, okay, minus my LCD, which happens to be x plus 1, x minus 1 over 1, times my original term in the problem, which is 2 over x plus 1, x minus 1. Okay, here we go. Now we get to do probably some of the most fun stuff that we do in math, right? And that's just getting rid of things and canceling it out. Doesn't it feel so gratifying to just get rid of it? Okay, so here we go. X plus 1s, those divide out, correct? So in this particular term, I would encourage you, if you're ever stuck or you're like, oh man, what can I get rid of and what can I not get rid of, right? It's got to be multiplication in order for you to divide things out, correct? Because multiplication, remember, a fraction is just multiplying straight across, right? So this is essentially just one fraction, yes? Where if you had a subtraction side, so if you guys look on the right-hand side of the equal sign, you have a subtraction sign here, right? So I can't divide this x minus 1 with this x minus 1 with that x minus 1, right? So I would encourage you, if you're ever confused, to put a box around that term, right? Around that multiplication, so you know just inside of that box is what I can get rid of, right? So x minus 1 goes away, and then on the right-hand side of that minus sign, I have an x minus 1 that can go away, and an x plus 1 that can go away, right? Alrighty, what do we have left? We have an x minus 1 times 3 on that left-hand side of the equal sign. We have an x plus 1 times the 1 minus, all we have left for that last term then would just be a 2, correct? That's awesome. All right, let's do this then. We're going to simplify. We're going to distribute these through, so that's 3x minus 3 is equal to, distribute that 1, that really means nothing, so that's x plus 1 minus 2. Again, it's a linear equation, so all we have to do is get the x's by themselves and the numbers by themselves. So I'm going to subtract x here, subtract x there, so I'm left with 2x. I'm going to add 3 to this side, add 3 to this side, so my x's, I kind of did that pretty quickly, sorry. Those go away. That goes away. So then this right here, so that's plus 1 plus 3 minus 2. So that would equal 2. Divide by 2. Divide by 2. I get x is equal to 1. Awesome. Okay. Now, this didn't happen in the previous examples. It obviously happened here since we talked about it just a second ago. My solution is x minus 1. But what do you notice that x minus 1 also is? Hopefully you guys all remember from back up top that x minus 1 here is also an excluded value, is it not? So if x minus 1 is an excluded value, can it be a solution? No, because 1 would make the denominator 0, which would make the entire equation undefined. Does that make sense? So 1 can't be a solution. Therefore, we have no solution. Okay? So my answer here would be no solution. The cool part is, hopefully you want to use some math words here. X minus 1 is not just not a solution, right? X minus 1 is an extraneous solution. Does that make sense? So it's a solution that you get, but it's a solution that makes some part of that equation undefined. Therefore, it is not a solution. All right, let's do example 2 here. Okay. Example 2. So remember, first step, you have to factor the denominators. Well, the only one that we can factor here is this denominator here on the right-hand side of the equal sign. So that would be x plus 3, x minus 1, right? Okay, so now all of them are factored. We said that step 1b would be to find the excluded values. And the excluded values in this particular case are x cannot equal -3 and 1. Yes? Y'all agree with me there? Okay, again, you just set those factors equal to 0, right? Okay. All right, my LCD in this particular case would be what? X plus 3, x minus 1, right? All righty, let's get started. So then the third step we're already at. We're cruising along here. Time flies when you're having fun, right? Multiply every term by the LCD. So let's do that. My LCD here is x plus 3 times x minus 1. So that's x plus 3 times x minus 1 over 1 times the original term, right, or that first term in my equation, which is 2 over x plus 3. And that's minus the LCD, which is, I'm actually going to get rid of this, guys. I'm going to run into that. So I'm going to erase that real quick. And then I will continue. So I'm going to multiply the LCD then, again, by the second term in the equation, which is 1 over x minus 1. Okay. And then there's an equal sign. And I'm going to multiply the LCD of x plus 3 times x minus 1 over 1 by negative x squared minus 3x. All right, over, x plus 3, x minus 1. All right, let's start doing the most fun part of math here. When we're dealing with rationals is dividing the factors out that are the same. So again, I'm going to put a box around the multiplication so I know what I can divide out. So that's x plus 3's that I can do away with. Box around my second term. The x minus 1's are what I can do away with. Okay. And then on the right-hand side of my equal sign, I can do away with the x plus 3's and the x minus 1's. All right, so what do I have left here? I have an x minus 1 times 2 minus an x plus 3 times 1 is equal to negative x squared minus 3x, it looks like. Okay? All right, so now let's just simplify, guys. We're going to distribute through. So that's 2x minus 2. Here's the trickiest part of all of this, guys. Whenever you're subtracting a polynomial, I guarantee you people are going to make this mistake on the test. Do not be that person, please. Do not be that person. You have to distribute this negative to both of these terms, right? Because it's really like a negative 1 out in front of your parenthesis, right? So this would be negative x minus 3 is equal to negative x squared minus 3x. Okay, now what's different about this particular problem is that this is actually a quadratic, not a linear equation, right? And again, the reason it is that is because the highest exponent is 2. Your ability to put names to things is so vitally important that it's not even funny, right? Because if I know this is a quadratic, now I'm not getting x's on one side and numbers on the other side. I'm getting everything to one side to set it equal to 0, right? And that's, I know that's how I solve a quadratic. So first thing I'm going to do is clean up the left-hand side here. So that's 2x and negative x, and then negative 2 and negative 3. So 2x and negative x make x. Negative 2 and negative 3 make negative 5. So that's equal to negative x squared minus 3x. We just said that this is quadratic, so we're moving everything to the left-hand side. And the reason we're moving everything to the left-hand side is because we always like our a term for our quadratic to be positive, right? It makes it easiest on us. So I'm going to add 3x to both sides, okay? And I'm going to add x squared to both sides. Again, x squared doesn't have a like term on that side, so I'm not adding it to anything, okay? So on the left-hand side now, I have x squared plus 4x minus 5 is equal to 0. I can now factor, right? Remember, factoring is one way to solve a quadratic. If you wanted to use a quadratic formula, you're more than welcome to do that. You could graph it, remember, and look for the x-intercepts. But I'm going to factor it. And that the factors would be what? X plus 5, x minus 1 is equal to 0. So my solutions here would be x is equal to negative 5 and x is equal to 1. Okay? Those are the solutions I got when I solved it. But based on what we talked about up top again, odds are there's probably going to be an extraneous solution in here. And there is, right? That extraneous solution is x equals 1, is it not? Because x equals 1 is also, if you guys can look up here, is it an excluded value as well? Okay, and if it's an excluded value, we know it cannot be a solution, right? So x equals 1 is an extraneous solution. Therefore, it is not part of my actual solution. So the only solution I have here for this particular problem is x equals negative 5.